So in this example, I thought we could show that 2 to the power of n is greater than or equal to n plus 1 for all n greater than or equal to 0. So now the base case, which is n equals 0, we have 2 to the power of 0, which is 1, which is indeed greater than or equal to 0 plus 1, which is 1. So this works. So now we need to do the induction. So our induction assumption is that 2 to the power of n is greater than or equal to n plus 1 for all n equal to 0 all the way to some fixed n which is greater than or equal to 0. So now what we do is we consider 2 to the capital N plus 1. So this thing, right, can be written as 2 times 2 to the n, which is 2 to the n plus 2 to the n. And by the induction hypothesis, right, so that's this assumption up here, we have that each of these terms is greater than or equal to n plus 1. Now, n is greater than or equal to 0, so we can replace one of these n's by, say, a 0. And then this side here is n plus 1 plus 1. So what we've shown is that this thing holds with n plus 1 replaced, and so this completes the induction.